So that's it for the brief side quest in Chapter 2 for our course. And we might go back to Chapter 2 later if there's, if we actually finish what we need from Chapter 1. But I suspect that the rest of the course is just going to be in Chapter 1. There's a lot of stuff there. Yeah, so in the next lecture we'll be going back to Chapter 1, picking up from where we left off. And here I've put the list of all the terminology that uses the word measure or measurable, and these all mean different things. So right now we have learned about these three. We picked these up from Chapter 1, and we just picked this up from Chapter 2, and we're going to go back to Chapter 1 and pick up these next. So I went into Chapter 2 because I want you to get exposed to the idea of a measurable function, regardless of whether or not we have enough time to finish Chapter 1. So I guess because it's interesting and it's good to see, when you learn about a new kind of mathematical structure, it's good to learn about the mappings that also preserve that structure, right? Like when you learn about groups, you also learn about group homomorphisms. When you learn topology, you learn about continuous functions. When you learn about a measurable space, you also want to learn about the functions that preserve its structure, and those are the measurable functions. So that's sort of why we did that. So also, you've probably heard this term before, random variable, at least being thrown around kind of informally, maybe in a high school statistics class, or if you're a stats person, you probably know a lot more about it than me. But if you look up like what actually is a random variable in probability theory, there's this kind of informal idea that it's a variable whose values depend on outcomes of a random phenomenon. But for the formal treatment in that context, a random variable is understood as a measurable function on a probability space. So we have not defined probability space. We'll probably actually say what that is next time. But measurable functions, these things we just picked up from Chapter 2, are what random variables are. So if you go look up the definition, a random variable is a measurable function. And these are measurable spaces, omega and e. So these are this idea of a measurable function is definitely an important concept that's used everywhere. And if you look at what this probability space thing is, if we go down to the definition, it's a measure space. Okay, which is not the same as a measurable space. We already know what a measurable space is, a set with a sigma algebra. A measure space is three things. A set, so a set, which we're calling the sample space in this context, a sigma algebra of things which are called, it consists of what they call events in probability theory. And the third thing is the probability measure, which is an example of a measure, which is the next topic. So that's what we'll talk about on Monday. However, I should mention that I really do not know probability theory, so I feel weird even talking about it publicly. But what we'll get into is the mathematics, and then if I can learn some things and introduce some probability flavor into there, then I'll try to do that.